Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I would like to talk to you about the jolting sun. Now, the sun has been having some strange motion. It seems to be wobbling, or I like to call it jolting lately. And in fact, it has done that before, and I wrote this article a little while ago, and it refers to this type of jolting motion that it was seen to be having on January 25th, 2017. And on this day, the sun was seen to shake roughly, and the shaking was attributed to the STO satellite being shaken. However, close examination of the images detected by the STO satellite revealed that something much stranger was going on. In fact, I think the sun was actually moving, but we are going to look at it more carefully. So figure 1 shows images of the sun detected by the STO satellite in the 21.1 nanometer wavelength on January 25, 2017 between 1458 and 1503. So let's look at those images. So this one is from 1458. This is the second image from 1459. And if we compare these two images, we can see that the bottom of the sun has moved downwards. We can compare it with these bars at the bottom of the image. We can see it has moved down. So we see more of the corona on the side, so the sun has moved to the left. Then in the next image, we see the bottom has moved up, so the sun has moved up, but we see even more of the corona, so it has moved even more to the left in this direction, therefore. Then in the next image, the sun seems to move this way because we see less of the corona on the right-hand side than we did there. Then we also see cutoff lines being used. These are diagonal lines that hide part of the corona. It is almost vertical, so here is an image, a larger image, where we can clearly see that a cutoff line is being used. So now the fact that we have cutoff lines being used, let's look here, shows that obviously something was there that someone needed to hide, or NASA needed it to be hid. So because there is no point to actually adding cutoff lines to images if they have no purpose, and the most likely purpose is of course to hide something. Now, if the sun seems to jolt, as we saw in figure 1, it would seem logical that it is the satellite that is moving rather than sun, because the sun is an extremely large object, and moving it should require extremely large forces. However, if that was the case, there would be no need to hide any part of the sun's corona. Because then there would be no objects that would be interacting with the sun and causing it to move. It would just be the satellite. So one of the reasons why I think the sun was actually moving was the fact that cutoff lines were being used. Also, if the satellite had been moved, what could have caused it to move? Perhaps a tiny impact with a meteorite. There is no atmosphere. This is a geosynchronous satellite, very high altitude. So perhaps a tiny meteorite impacted it. But then the chances that the satellite is impacted by other meteorites coming from different directions in the space of 3 minutes is extremely small, and therefore just about impossible. Because what would have to have happened was, for the detector to see the sun moving in this direction, the satellite would have had to have been impacted by a meteorite coming from this direction. So it moved this way, so the sun seemed to move in the opposite direction. But then to get the next image, the satellite would have had to have been impacted from this direction. And then for us to see the next image like that, the satellite would have had to be impacted from this direction. So that's 3 different directions in the space of 3 minutes. and extremely unlikely. If meteorites are coming from somewhere, they will all come from one direction. So then 12 minutes later it happens again. So these images are in 19.3 nanometers. We see the cutoff lines are still being used in the first two. And then in the next images we see that the sun moves down. This is further down, and it has moved to the left, slightly to the left. And then in the next one it moves in the opposite direction. So up again and to the right. And the motion to the left and to the right is slight, but it is still there. There's a little bit less of the corona here than there is there, and there's a little bit more here than there is there. And then the cutoff line is almost vertical, but in these larger images we can clearly see that it was there. Then 13 minutes later, it happens again. We have the same cutoff lines. Notice that the sun is out of focus, showing that it was in motion when the image was taken. And again, we see that there's less of the corona on this side, so it moved to the left, and it also moved upwards in relation to its position here. Then in the next image, it moved in the opposite direction, so we see more of the corona, and we see that it's moved downwards. So the sun jolts carry on happening at 9 to 13 minutes until 21:31, and therefore for 6.5 hours. And so this is tabulated here, all the motion between 14:59 and 21:31 on January 25th, 2017. So in the first column, we have the time of the sun's jolting motion. So this was from 14:59 to 15:01. And we saw these subsequent motions in these directions indicated by the arrows. The second column shows the time difference between subsequent jolts. So between this one and that one, there was a time difference, a time period of 12 minutes. So as you can see, there was a lot of jolting motion until 21:31. And in the fourth column, we have it shows whether the cutoff lines were being used and where they were being used, because they were used on different sides of the images. And then in figure 6, we have what happened in the jolting motion of the sun between 1718 and 1721. And we see here there was, the cutoff line was not there anymore, it was here. And the motion is now in the direction of the cutoff line, and then in the next minute it's in the opposite direction. So you can see the sun is lower than in this image, and we see here is the corona, and in this image we can definitely see less of the corona. So the sun has moved to the right. Then in the next image it moves in the opposite direction. So slightly upwards and a little to the left. Then we see that these are images from 1526 and 1719, and in both these images the sun was in motion towards where the cutoff line was. So possibly there was an object being hidden by that cutoff line over there, and then by this one, and the sun moved in the direction of these cutoff lines. Then the same thing happens over and over again. We again see the sun is in motion because it's out of focus. The motion here, and this was the last motion seen on that day, we see it became quite dramatic. In fact, I said that the sun was bouncing around like a ping pong ball here. So as you can see, it moved down and to the left here. There's a lot less of the corona here. And then it moved in the opposite direction, it moved away from the side to that side. And then it didn't move down, but it moved left again, and then it moved upwards again, and then it came back to the original position. So that was a lot of motion. Then we have images in another wavelength, the 33.5, and again this is also in the last motion that we saw for the day. So from 2127, 2132, we see that in this wavelength the sun clearly has the same type of motion, diagonally down, diagonally up, to the left and upwards. Thus, from the sun's obvious jolting motion, the use of image cutoff lines to obviously hide unknown objects close to the sun's surface, and sometimes the sun's motion in the direction of the image cutoff lines, as shown in Figure 7, it can be concluded that the sun is jolting as a result of objects coming close to it and affecting it. Now, this means that the sun is moving with respect to the Earth, but if the Earth is attached to the sun as it should be, the Earth should automatically, instantaneously follow any movement that the sun has, and therefore we should not be able to see any motion of the sun. The fact that the sun is now moving with respect to the Earth suggests that the Earth is no longer attached to the sun only, but to the group of stars, including the sun, that are now in the nucleus of the solar system. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.